Hey everybody, it's Ms. Phoebus, and this is lesson 44. We're going to combine writing and solving quadratics in a word problem and average rate of change revisited. So we have more quadratics. These are not our trajectory problems, but they are going to be some more word problems, mostly having to do with area and perimeter and things of rectangles and squares. And then we're going to, of course, do a little bit of average rate of change. Why not? Sounds good to me. All right, so our skills, we are looking at skill 57. I can write equations of quadratics when given a table, 2 points, or other key characteristics, including the dimensions of a rectangle to calculate the area of a figure. We're also reviewing skill 20. I can calculate average rate of change from a nonlinear graph, table, or function, and we're really actually going to look at the function component. So our standards that we're going to look at today, we're going to create equations in one variable, and those are going to be quadratic equations, and we're going to use them to solve problems. We're solving quadratic equations in one variable using various methods, and then we are going to write a function defined by an expression in different but equivalent forms to reveal and explain different properties of the function. And then we are also calculating and interpreting the average rate of change. We're going to look at it presented symbolically, again, over a specified interval. So we are on page 179 in your notes. And on page 179, you have this stuff that we're going to fill in the blank. An application of solving quadratic equations comes from the formula for the area of a rectangle. This can be calculated by multiplying the width and the length. To solve problems with rectangles, we will first draw a diagram to represent the problem. If you notice, I have a rectangle already drawn, and we're going to use it to write our equation. So here we go, problem number 1. The length of a rectangle is 3 more than its width. If the area is 40 square inches, what are the dimensions? Now, I know some of you would just jump straight into the numbers, but that's not the point. We're going to be writing and solving equations. So let's label these. We know we have length and we have width. But the length is 3 more than the width. So we want to get this in terms of one variable. So if I take the width and add 3 to it, I will get the length. So we are going to be working with W plus 3. That will be the same as our length, and W as our width. So if the area is 40 square inches, well, how do you find the area of a rectangle? Well, you take the length and you multiply it times the width. But remember, we're going to use W plus 3. So if I have W plus 3 times W, let's put that W out in front. So length times width equals 40. We're going to solve. Now, you cannot do the zero product property with a number other than 0. So you can't say W equals 40 and W equals 43 or anything like, or 37 or whatever you want to say. You can't do that because it has to be the zero product property. So what we're going to do is we're going to distribute this W. And we're going to get W squared plus 3W equals 40. And we have to make this equal 0. So W squared plus 3W minus 40 equals 0. Now, they do not give us any sort of guidance as far as do they want us to factor, do they want us to graph, do they want us to complete the square, do they want us to use the quadratic formula. They don't tell us any of this stuff. So on your test, which is tomorrow, you have to choose the method to solve that I give you. You have to. So if I say solve by factoring and you run the quadratic formula, nope. If I say solve by taking square roots and you run the quadratic formula, nope. Okay, you have to use that method that I've asked you to. Now in this case, it equals 0, we have options. We could run the quadratic formula, we could check to see is it factorable even. That's probably where I'm going to go because I'm pretty sure I can come up with two numbers that multiply to give me negative 40 and add to give me 3. They are 8 and negative 5. But if you want to run the quadratic formula, you can. So that's kind of, you're starting to get those options. All right, so let's factor. So I'm going to have W plus 8 W minus 5 equals 0. And so if W plus 8 equals 0, W equals negative 8. And if W minus 5 equals 0, W equals 5. Now, will our width be a negative number? It will not. So we will get rid of the negative. Anytime that happens, we get a negative number and it doesn't make sense in this situation, we throw it out. So that means our width is 5. And what would our length be? Well, we would take the 5, add 3, so our length would be 8. And since this is in square inches, let's get our units on there. Okay, so that's what we're working with. We're working with using quadratics and the factoring and all of that component, or quadratic formula or what have you, to help you figure out what the dimensions of this rectangle are. And it can go into gardens, it can go into, I think there's one on the practice end, of course, that's about a farmer in a field, and it's got all kinds of stuff like that. So just keep in mind that there are lots of different ways to phrase the question, more so than just a rectangle. It could be a garden, could be a swimming pool, could be a picture frame, something like that. All right, so number 2, if each side of a square is increased by 6, the area is multiplied by 16. Okay, so we're going to find the side length of the original square. So let's think about this. So we know squares have equal sides, right? And usually we would be taking, here's my sides, for my original, which we don't know a whole lot about right now, we know that the area is equal to side squared, right? Or you could do side times side, which is side squared. But then each side is going to get increased by 6. So let's change that to s plus 6, s plus 6, s plus 6, s plus 6. And that means that when I go to find my area, it ends up getting multiplied by 16. Okay, so my area is 16 times the area of what it used to be. And then this is no longer s squared, this is s plus 6 squared. Now, we are going to have a very hard time solving for 2 variables. So notice here that I already know that the area can be replaced. I can change out a and put in its place s squared. So let's look at 16 s squared equals s plus 6 squared. And let's see if we can't solve that for our variable. So the very first thing you need to do is you need to multiply this out. Remember, 2 parentheses that match. So it's going to be 16s squared equals s plus 6 and s plus 6. So we get 16s squared equals s squared. Here's 6s and another 6s, so that's 12s. Plus 6 times 6 is 36. Now I have to make this equal 0, so I have some options. I can bring everything over to the left, or I could subtract 16s squared and get 0 equals negative 15s squared plus 12s plus 36. Now you may be like, Miss Phoebus, what are we going to do? Well, we have some options. We could factor out a greatest common factor. We could factor out a negative 3, and we might have to do slide and divide. So let's look at running the quadratic formula. Why not? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so negative b is going to be a negative 12. Plus or minus the square root of 12 squared minus 4 times negative 15 times 36 all over 2 times negative 15 is negative 30. Negative 12 plus or minus the square root of 2304. I wonder if that is a perfect square. Oh, it is. Okay, I'm going to get rid of that. Square root of 2,304 is 48. We're going to divide it by negative 30. Now, there's two answers built inside. Remember, one with a plus and one with a minus. So let's do negative 12 plus 48 over negative 30. And remember that this is the side length. So negative 12 plus 48 divided by negative 30 is negative 1.2. And we don't know anything about units, so that would be whatever our units are. But do you see how it's negative? So we're probably going to throw that one out. If both of them get thrown out, then we would say that's impossible to do. But I have a feeling this one's going to work. Negative 12 minus 48 is negative 60 divided by negative 30, and that's going to be 2. So that means that the side length is 2. So our side is 2. That would mean that our area would be 4. And then if I increase my side by 6, that would mean my new side is 8. Then the area would be 64. And if I took 4 and multiplied it times 16, I would get 64. So find the length of the original square, the side length. There is our side length. Side is 2. We didn't have any units. You could put 2 units if you really want to, but side length is 2. So you can do the quadratic formula. If we wanted to factor, it should have been able to be factored, and we should have gotten the same answer. All right, the area of a rectangle is 48 feet squared. Its perimeter is 32 feet. Find its length and width. So we've got 2 equations that we have to write. We have to write one about the area of a rectangle, and then the other about its perimeter. So let's think about this. Area of a rectangle is length times width, right? And we know that that area is 48. So here is our equation. 48 feet squared is length times width. All right, we know perimeter is 2L plus 2W equals 32. There we have that. And what we want to do is we want to find the length and the width. We don't want to just be chugging and plugging in different numbers. We want to actually come up with a method. So what we can do is we can solve for one of these variables. So let's say we wanted to solve for the length. So remember our literal equations? Let's get L by itself. That would mean I would have 2L equals 32 minus 2W, and then divide everybody by 2. So I'd have L equals 16 minus W. So this is one of the applications of our literal equations, is being able to help us. Now we're going to substitute. We're going to work more with this next or later this week, substitution. We're going to substitute the 16 minus W in for L. So that means I can rewrite this as 16 minus W times W equals 48. So I have this set up for you. I want you to distribute that W. I want you to get everything on the same side, and then I want you to either run the quadratic formula or try to factor or something. I need to know what W is. So pause the video. All right, if we distribute, we get 16W minus W squared equals 48. I probably want to move everything to the right-hand side so that my W squared is positive. Oops, I should be subtracting minus 16W to make this equal 0, right? Can't have it equal 48. So W squared minus 16W plus 48. Let's see if we can come up with 2 numbers that multiply to give us 48. Those same 2 numbers have to add to give us negative 16. Well, I am thinking negative 12 and negative 4. Okay, so that means that W minus 12, W minus 4 equals 0. And so that would mean W equals 12, W equals 4. And if you ran the quadratic formula, you should be getting the same thing. Now I have 2 widths, And the question is, okay, if I have two widths, what would the lengths be? So to get the 48 feet squared, I would have to multiply this 12 by 4. And to get the 48 feet squared, I would multiply this width by 12 to get 48. So basically, it doesn't matter which one you're looking at both dimensions. So whether you call the length 12 and the width 4, and these are in feet. So if they give you units, I want to see units. Or if you call the length 4 and the width 12, it's going to be the same. It just depends on what you're going to be calling the length and the width. All right, so our length and width are 12 feet and 4 feet. So we have an 8-inch by 12-inch pitcher. So the pitcher itself is 8 by 12. And it is in a frame of uniform width. So that means that even though it's not a good pitcher, this piece and this piece are the same, as well as this and this. So we're looking at those lengths, the width of the frame being the same measurement. The area of the frame is equal to the area of the pitcher. That's interesting. So the area of the frame equals the area of the pitcher. We're going to need to use that because I have a feeling we're setting up like an area of the pitcher, area of the frame, and then make them equal to each other. What is the width of the frame? Okay, so let's find the area of the pitcher. That's going to be the easy part. So the area of the pitcher is 8 times 12. 8 times 12, which ends up being 96 inches squared inches. Okay, the area of the frame is a little bit different because we have to look at the whole entire width and the whole entire length. So when I look at the length, I have the 12 to represent this piece, but I have to also add x here and x here. So I have to add 2x to the 12. So that gets me the length. And then let's switch colors. So then here I have 8 for my width, but I also have an x here and an x here. 1x and 1x is 2x. So my width is 2x plus 8. So let's come over here. Our area of the frame equals area of the pitcher. So my area of my frame is going to be length times width, 2x plus 8 times 2x plus 12 equals the area of my pitcher, which is 96. Okay, now if I was going to be cutting something out, I would be subtracting areas. But in this case, they told me that the frame's area is equal to the area of the pitcher, so we have to use that piece. All right, so 2x, I'm multiplying, times 2x is 4x squared plus 24x plus 16x plus 96, that's nice, equals 96. And then I can move this over as well as combine some like terms. So I have 4x squared plus 40x equals 0. Now, we could factor out a greatest common factor of 4x and be left with x plus 10 equals 0. And then we could set each one equal to 0. 4x equals 0, so x equals 0. That means that there is no width to this frame. All right, so let's play around with this. This is x equals negative 10. Let's see what happens there. So if I plug in x equals negative 10 and do 2 times negative 10 plus 8, I get negative 20 plus 8. That is negative 12. All right. Let's look at 2 times negative 10 plus 12. Yeah, that ends up being... Okay, so here's my thought. The frame width could be 0, but I don't think this is happening because I've got a frame width of 0 and a frame width that owes me something. I don't think this is something that could happen. So we will write no solution. So our answers sometimes don't work. Great to know. All right, let's try another one. A rectangular lot is 20 yards longer than it is wide. The area is 2,400 square yards. Find the dimensions of the lot. This one's pretty easy. I'm going to let you set this one up. See if you can figure out what the answer is. Pause the video. All right, so this is very much similar to the first one that we did. So we know that the length is 20 yards longer than it's wide, so the width plus 20, whereas this is the width. The area, which is length times width, is 2,400 square yards. So what we're going to do is we're going to plug in W plus 20 times W equals 2,400. And we're going to distribute. So we get W squared plus 20W equals 2,400. And then we're going to subtract 2,400. Make it equal 0. You can try to factor this. You can run the quadratic formula. Well, you could try completing the square as well. I don't know if I would, but that is something that you could try doing. I'm going to do the quadratic formula. So x equals, it would actually be w equals negative b, but x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 20 plus or minus the square root of 20 squared minus 4 times 1 times negative 2,400. I'm running into my work. All over 2 times 1 is 2. So let me grab my calculator. And 20 squared minus 4 times 1 times negative 2,400 is 10,000. So negative 20 plus or minus, I think I can take the square root of 10,000. And I get 100 all over 2. So negative 20 plus 100 is 80. 80 divided by 2 is 40. And then negative 20 minus 100 is negative 120 divided by 2 is negative 60. So we're going to throw one out. Do you know which one we're throwing out? We're throwing out the negative. So that means that W is 40. So that means that 40 plus 20, the length is 60. So 40 and 60. So the goal is to write the equation and then use the quadratic stuff that we've been learning to solve that equation, not to mess around with the numbers and just shove them in a calculator and just be picking numbers and trying them. That's not the purpose of this. The purpose is to write equations. All right, in a landscape plan, a rectangular flower bed is designed to be 4 meters longer than it is wide. If 60 square meters are needed for the plants in the bed, what should the dimensions of the rectangular bed be? All right, so we want the length to be 4 meters longer than it is wide. So width plus 4, there we have width. We've got area equals length times width, and we know we need 60 square meters. So let's set this up. W plus 4 times W equals 60. So let's distribute. W squared plus 4W equals 60. W squared plus 4W minus 60 equals 0. I think we could factor this one. Can we find two numbers that multiply, give us negative 60, and add to give us 4? We got 20 and 3, 12 and 5, 10 and 6, 10 and 6, 10 and negative 6. All right, so that's W plus 10, W minus 6. All right, so that means W equals negative 10. How do you feel about that? Yep. Throw it out. W equals 6, however, that should work. So we should get 6, and 6 plus 4 is 10, and 10 times 6 is our 60 square meters. So let's get some meters on there. Got our units. There we go. Okay, so throw out the negatives, and if you have to throw out both answers because they don't make sense, then there isn't a way to do it. You're basically trapped in a in a problem that has no solution. All right, in your own words, explain what average rate of change is. What do you guys think? Average rate of change. Average rate of change, we talked about it in the slope lessons. It's slope, but these are quadratics. These are not linear functions. So this is slope of nonlinear functions. Okay? And so I'm going to be given two x values. They're going to write it a couple different ways. So here is an x value. Here is an x value. We can call this x1, this x2. But in order to run slope, which is y2 minus y1 over x2 minus x1, get slope, we need some y values. Here's x1 and here's x2. But I have to have y values in order to do this. Okay? So what we're going to do is we're going to pick x's. We're going to plug them in. But we can't just pick any x. We have to pick x's that are given to us. So we're going to plug in -1. Work that out. Some of us are not following order of operations. Then we're going to plug in 0. Work that out. Get 2 points. And then we're going to do slope. So for the first one, -1 squared is 1. 1 times 2 is 2. 2 minus 1 is 1. So I'm looking at -1, 1 as a point. 0 squared, 0. 2 times 0 is 0. 0 minus 1 is -1. I'm looking at 0, comma, -1 as a point. I want slope. So we're going to use y2. So I'm going to do -1 minus 1 over 0 minus -1. -1 minus 1 is going to be -2 over 0 minus -1 is 1. The slope is -2, and that's my average rate of change. Okay, so a lot of times you benefit from seeing this again. The first time it might not have clicked. The second time it maybe will click a little bit better. And we're going to keep coming back and hitting it because average rate of change is something that we will have on our end of course test, and we want to make sure, I want to make sure that you know it. All right, so we've got our two x's. Let's plug them in, and you can type this in the calculator. You do not need to do it all mentally. And then we're going to plug in 2. And when you plug it in, you've got to make sure that you are plugging in everything accurately. So 1 squared is 1, 1 plus 3 is 4, 4 minus 2 is 2. So I've got 1 comma 2 as a point. 2 squared is 4, plus 3 times 2 is 6, so 4 plus 6 is 10, 10 minus 2 is 8. So my other point is 2 comma 8. Now I want to find the slope between those 2 points. So I'm going to do 8 minus 2, change in y, over 2 minus 1, change in x, 6 over 1, which is 6. That's my average rate of change. All right, we've got a couple more, and then we'll be done. Compare the average rate of change of 1/4 x squared plus 1 and y equals 2x squared between 2 and 4. So what we're going to do is we're going to do average rate of change for each one, and then we're going to compare. And maybe one's steeper, one's maybe negative. We'll compare them. So we've got two like this. And so what I'm going to do is I'm going to split this into 2 workspaces. So I'm going to have 1/4 times 2 squared plus 1 I'm going to have 1/4 times 4 squared plus 1. And then I'm going to have down here 2 times 2 squared. Not plus anything, because I'm switching functions, and then 2 times 4 squared. And then I'm going to get a series, 2 sets of points for the stuff in blue, 2 sets of points for the stuff in green, do slope 2 times, and then get a final answer that I can compare them to. All right, so let's look at these guys. So we're going to do exponents first. So 2 squared is 4. 4 times a fourth is 1. 1 plus 1 is 2. So I'm looking at, I plugged in a 2, comma 2. And then 4 squared is 16. 16 times a fourth is 4. 4 plus 1 is 5. So I plugged in a 4, and I got a 5. So you could go ahead right now and do the slope if you want to. 5 minus 2 over 4 minus 2. 5 minus 2 is 3. Over 4 minus 2 is 2. So my slope is 3/2. All right, the other one, I've got 2 squared, which is 4. 4 times 2 is 8. So I've got 2 comma 8 as a point. And then I have 4 squared, which is 16. 16 times 2 is 32. So I also have 4 comma 32 as a point. Let's do the slope there. So I'll have y2 minus y1 over x2 minus x1. So 32 minus 8 is 24. Over 2 minus 4 minus 2 is 2. And I get 12. So I would say the 2x squared has a greater average rate of change. Do you see it? 12 versus 3 over 2. And that's because we have a 2. Our A value in the front is 2 versus this vertical compression. We have a vertical stretch by 2 or a vertical compression by 1/4. So we should expect 2x squared to have a greater average rate of change in comparison. All right, so let's do one more. All right, we're going to make a little change. So what you need to do here is you need to change this to a squared, negative x squared, because we're comparing quadratics. So I don't know what happened there, but we lost a squared. All right, so we're going to cut this into 2 areas, 2 work areas, and we're going to do, remember this is x1, this is x2. So into my first function, I'm going to plug in a 0, and then I'm going to also plug in a 3. And then I'm going to do the same thing with my negative x squared, plug in a 0, and then plug in a 3. And then remember, we're going to get points. We're going to compare slopes and look at those and make a statement about it. So 0 squared is 0, 0 times 2 is 0, so we've got a point 0, 0. 3 squared is 9, 9 times 2 is 18, so this is going to be 3 comma 18. And then let's do slope. So we'll have y2 minus y1 over x2 minus x1, which is 18/3, which is an average rate of change of 6. And then let's do 0 squared is 0, so we've got 0, 0. That's the same. This is a negative. 3 squared is 9, so we've got 3 comma negative 9. And then we're going to have negative 9 minus 0 over 3 minus 0. So that's negative 9 over 3, which is negative 3. So which one has the steeper slope? That first function, right? F of x has a steeper slope, but g of x has a negative slope. So we can say f of x has a greater average rate of change, right? But g of x has a negative average rate of change. So you usually talk, when you compare, you usually talk about things that are interesting. So they're different, right? One number is bigger than the other, but that negative also means that it's decreasing on that side of the function. All right, so you have a test tomorrow. You also, my virtual kids, we're going to be doing this in class on Thursday, but I sent you an email that said do not delete that had a password in it for something called SchoolNet. So I'm going to have to make some instructions on how to do this SchoolNet thing, but I've never actually been in there. So I'm gonna wait until the kids like actually take it's like an assessment that the state wants you to do, and we have to give it. I don't know what it looks like. I'm gonna give you a video maybe of me talking you through it, but I don't know. We'll just have to log in and see how it goes. Look for an email from me, maybe with some more instructions on it. I might not do a video now that I think about it. All right, guys, hey, good luck on your test tomorrow. Don't forget to have your graphing calculator and your notes available, and I'll see you in the next video. Bye.